Alright, so today we're going to be going over partial derivatives. So we have question 9 here, which is f of x and y is equal to x to the 4 plus 5x multiplied by y to the 3. Now to start, what we're going to do is we're going to find f and take the partial with respect to x. Now what it means for partial derivatives is anytime, since we're solving for x, any number that's a constant will stay a constant and we'll treat it just like normal. But anytime you see a y, we're going to treat that like a constant as well. So since it's a derivative and it's adding, we'd split it up into two separate derivatives, which is just the exact same steps as normal. So x to the 4 will become 4x to the 3. Now plus, and we're going to take out the 5, and we're going to take out the y to the 3, and we're just going to deal with the x. And we're going to treat both of those just like constants. Now the derivative of x just becomes 1, so we can ignore this. And we have our answer here. We have our partial derivative of x to the 4 plus 5xy to the 3 with respect to x. It's just 4x to the 3 plus 5y cubed. Now, if we want to find the same equation but with the partial in respect to y, which you'll have to do if you do double integrals later on, you'll have to learn both, we're going to treat x like the constant. And if you remember, anytime you take the derivative of a constant, it just goes away, it becomes nothing. So, since we're splitting it up into two different derivatives, and x to the 4 just becomes a constant to us, the x to the 4 will actually go away because it's a constant. Now we add 5xy to the 3, but we're treating 5 as a constant like normal, but this time we're treating x as the constant. So we have 5x, and we're going to just deal with y to the 3. Now our equation becomes 5x multiplied by our new 3y to the squared, because that's the derivative of y to the 3, and we'll multiply 3 by 15. So we get 15x y squared, and that's going to be the partial derivative with respect to y. Alright, next up we have question 10, which is f of x and y is equal to x squared multiplied by y minus 3 multiplied by y to the 4. So what we're going to do here is we're going to start off with the partial derivative in respect to x, which means that our y is going to be counted as just a constant. So we're going to write here y, or with multiplied by x squared, so we know that we're just working with x squared. And we can see here that since y is going to be a constant and 3 is a constant, this whole thing is going to be a constant. So when we're taking the derivative, this will all just get cancelled out, so we can just ignore it for now. We're going to write nothing. We're going to write minus 0 because there's nothing we're subtracting by. And now it's just an easy derivative. It's x squared, which is going to be 2x. So we're going to write the 2 up front, multiplied by y, multiplied by x. And that's our partial derivative in respect to x. Now we're going to find the partial with respect to y, which means that our x is going to be a constant. So we're going to write x squared up front, and we're going to write y, and we're going to subtract 3, because that's our constant here, because there's no x, and y to the 4. Now, again, it's just a simple derivative. It's going to be x squared. Our y is going to become 1, so it doesn't really mean anything to us. And this is going to be 4y cubed. So we'll write 3 multiplied by 4y cubed. And now this, let's clean it up a little bit. It'll be x squared minus 12y cubed. Alright, next up we have question 17, which is the partial of y multiplied by x plus y squared multiplied by y to the power of 5. So for this one, we're going to start off just like normal, and this one will be g of x. So we're going to start off with a partial with respect to x. Now this is going to make it a lot easier because our y is going to be a constant, so we can just leave that out front and we can deal with the inside, which if you recognized that something to the bracket, in brackets to a power of something, we're most likely going to have to use the chain rule, which we will here. So the chain rule is going to be the derivative of the outside multiplied the derivative of the inside of the bracket. So we're going to bring the 5 down, write the inside of the bracket the exact same to start, except put it to the power of 4, and now we're going to multiply it by the derivative of the inside of the bracket. But for partial derivatives, the inside of the bracket is still going to be the partial derivative of the inside. So our x is going to become 1 plus an x squared multiplied by y. Y is going to be a constant, so we can leave it there, but then our x squared will become 2x. And now, putting it all together, we get y multiplied by 5, so it'll be 5y, and then we'll have bracket x plus x squared y to the 4 multiplied by 1 plus 2xy. Alright, now we have to take the partial with respect to y. So we're going to have g with respect to y. Now this is where it gets a little bit more complicated, but still not too bad, because now our y we can't assume is a constant. We still have to deal with it. So these are two functions being multiplied together. So instead of just needing the chain rule, we'll need the power rule and the chain rule. So we'll do this step by step. So we'll need to take the derivative of the first function, which is our y, and then we're going to have to multiply it by the regular of our second function. And now we're going to have to add it by our first function multiplied by the derivative of our second function, which is going to be our x squared y plus x, I'll make that a little bit better, to the 5. Now the derivative of y just becomes 1. It's going to be multiplied by our regular x plus x squared y to the 5. And now our y is going to stay the same. And now we have to take the chain rule of our function here with respect to y. So we're going to start it by taking the derivative of the outside, which gives us 5x squared y plus x all to the 4. And now we're going to multiply it by the derivative of the inside with respect to y. So this will be x squared is going to be our constant because we're taking with respect to y, and our y is going to be regular. And we're going to take the derivative of that. And now we're going to plus x as our constant. But if you remember from our last couple of examples, anytime there's a constant, it just goes away. And this y just becomes a 1. So really all we need is our x squared from here. And our 1 can go away here because that doesn't change anything. So it'll become x plus x squared y to the 5 plus, I'll make this a little neater to make it 5y. And I'll make it even neater, we're going to bring our x squared over. So we'll make it 5y x squared multiplied by x squared y plus x to the 4. And you're all done, or you could simplify and rewrite it as x to the 5 multiplied by xy plus 1 to the 4 multiplied by 6xy plus 1. But depending on what your teacher wants, you could either leave it as this answer, or if they really want the simplified one, you could put it as that.